Let's look at some real life examples of how we can use addition and subtraction equations, or how we can set them up. Okay, so our focus right now is we want to start thinking more in terms of algebra. A lot of the examples, there are many different ways to figure them out, but we just kind of want to focus on the algebraic way of figuring them out. If you look at this example, it says the normal high temperature in January in Bismarck, North Dakota is 20 degrees Fahrenheit, and the normal low temperature is a negative 2 degrees Fahrenheit. How many degrees apart are the normal high and normal low temperatures? Okay, apologize for spelling that wrong. In this case, many of you would probably just say, oh, well, we know it's a difference of 22 because if you think of a number line, 20 goes to 0 and then you got to go down 2 more. Or maybe you would subtract them or something like that. But again, let's think of it in terms of an algebraic equation. We know we started at 20 degrees Fahrenheit. And obviously, if the low temperature is a negative 2, that means it's going to fall a certain number of degrees. So I'm going to think of subtraction. Okay, if we're taking away degrees or it's falling, I'm going to think of subtraction. According to the information up here, though, do we know how much it fell? No, we don't. Unknown. That's a variable. But we know when it fell this many degrees, it ends up at negative 2 degrees Fahrenheit. Okay, so this is just how we can set up an equation. If you look at this, though, you want to be careful when you're solving it because we're minusing the variable in this situation. Okay, so let's just focus on, well, let's go to our steps. Okay, so again, we had where we started, we're taking away how many degrees we fell, and that's going to leave us with negative 2 degrees. So if we're looking at this, we can ask ourselves, what are we solving for? Well, we're solving for the x. Okay, so if I'm solving for x, what do I have to get rid of? Well, on this side of the equal sign is this 20. How do I get rid of 20? Well, here's where I have to really understand what we're doing. Because when I ask myself, how do I get rid of the 20, some people will go, hey, it's subtraction, I add 20. But watch what happens when you add 20. 20 plus 20 is 40. Is that what we want? No. We want to get rid of this 20. So again, even though this is subtraction, we have to be careful of how we do it. How can we get rid of a 20? How can we get rid of positive 20? Notice what happens if I select a negative 20. Now if you combine our like terms, 20 plus a negative 20 is 0. It cancels out, and that's what we want. But whatever we do to one side of the equal sign, we have to do to the other. Okay? Now, this cancels out. We bring down our x, but notice here it was minus x. We can't forget about that minus sign. Or if you want to think of it in terms of keep, change, the negative sign or the negative 1, however you want to do it. Bring down your equal sign, and then negative 2 minus 20 or negative 2 plus a negative 20 will be negative 22. It's really important that you don't forget that this actually is negative, okay? Because it's asking us how many degrees apart. Well, how many degrees apart are 20 degrees and negative 2 degrees? It's not a negative 22. We're not interested in what direction they're going. And you can think of this as saying, well, negative 1 times what number would equal negative 22? Or again, when you have this negative sign, it's also an opposite sign. The opposite of x is a negative 22, so x has to be a positive 22. Always refer back to the original question. How many degrees apart are the normal high and normal low temperatures? They're 22 degrees apart. It's not asking us, did it fall, did it, go up 22 degrees? It just wants to know how many degrees apart they are, and that's 22. So when you finish a problem, a real life problem, make sure your answer makes sense. Let's just focus on setting up some equations here. You have X dollars and your friend repays you the $7 he owes you. You now have 9. How much did you have originally? Again, probably one you can do in your head, but let's write an equation. I have X dollars and he repays me $7. If he's repaying me, I'm getting more. It's an addition to, so I'm going to add. Okay? Pay attention to the cues in here. I now have 9. That means right now it equals 9. Okay? So again, we're just going to be practicing setting up equations. Okay? So, if you wanted to solve this, what are you solving for? X, what do you have to get rid of? 7. It's plus 7 or it's a positive 7. So we do the inverse. We subtract 7 or have a negative 7. Double check to make sure these cancel out. X equals 2. Does my answer make sense? I have $2 and my friend repays me 7, I now have 9. Yes, it makes sense. Again, always a good idea just to refer back to the question. Let's look at this one. The temperature was X degrees Fahrenheit. It fell 2 degrees and is now 7. So the temperature was X degrees. It fell, so I'm going to think of subtraction, 2 degrees, and is now 7. So now it equals 7. Okay? Paying attention to the key words in the problem. Okay? If you wanted to solve it quickly, we know we could add 2 to each side and get X equals 9. Doesn't make sense. The temperature was 9 degrees Fahrenheit. It fell 2 degrees and is now 7. Yes, that makes sense. Okay. One more. A 9-foot post extends X feet below ground, and 7 feet above ground. What is the length X buried below the ground? It's a 9-foot post. Oops. And extends X feet below ground and 7 feet above the ground. Okay, so it's 9 feet. Okay, we know the total length is 9. Okay, so if here's my post right here, right? Horribly. Let me cheat a little bit. Okay, here's my post right here. And sometimes it's helpful to draw a picture. We know that altogether this is 9 feet. We don't know how many feet it is below ground, but we know it's 7 feet above ground. So the whole thing's 9, it's 7 feet above ground. We probably can figure out what this is down here, but let's write an equation. Okay, so if our whole thing is 9 feet, okay, we take away how much it's below ground, we know we have to be left with what's above ground. Oops, I should put that over here. And that should equal 7. Another way we might think of this is to say, okay, I take how much it's above ground plus how much it's below ground, and that has to equal 9 feet. Okay? Either way you solve these, okay, keeping in mind right here, if you subtract 9 from each side, don't forget that this is a negative x or the opposite of x. So this would end up being the opposite of x equals -2. The opposite of what number equals -2? Well, that would be 2. Or if you set it up this way, if you subtract 7 from each side, because it's a positive x, you get 2. Okay? Does our answer of 2 make sense? How much is buried below ground? If the 9-foot post has 7 feet above ground, it has to be 2 feet below ground. Okay? So when you're solving equations, there are different ways we can set them up, but always make sure that your answer makes sense.